All right, everybody, this is a problem from the mastery, and I thought I would help you solve it and walk you through how to work these questions. So we're given this reaction, we're asked to balance this reaction. In order for us to balance this reaction, we have to split this reaction into its half reactions, the oxidation half reaction and the reduction half reaction. So for us to be able to do that, what you're going to want to do is go through and identify the oxidation numbers, which again is how we figure out who's oxidized or who's reduced over the course of the reaction. So I'm going to do that in green above each of these questions. So let's see if you can do this yourself. Go ahead and pause this video and see if you can figure out what the oxidation numbers are for this reaction. Go. All right, so let's do this. I know that iodide would be assigned first according to the hierarchy, and it would be assigned as a -1. There are 3 iodines, each with a -1, which makes -3 overall. I can see that chromium iodide is neutral, which means that this chromium has to be +3. Whatever we assign to chlorine, we double it, and it better get 0. So obviously that's just 0. Now let's take a look at our chromate. We have oxygen, which is -2. It gets assigned first according to the hierarchy of rules. It's a -2 times 4 of them, which is -8, which means whatever I add to whenever I add chromium to the -8, I better get a -2 back. So if you do the math just right, you should get +6 here. Again, oxygen gets assigned first, which is -2. -2 times 4 is -8. Whoop. And then, of course, whatever I add iodide, it better equal -1. So that would be +7. And then, of course, this chlorine here is -1. Chromium goes from a +3 to a +6. We can tell that's being oxidized. Notice that the iodide here is going from a -1 to a +7. So again, you'll notice it is losing negative charge, which means that it has to be oxidized as well. And then last but not least, we have our chlorine is going from a 0 to a -1. It's going more negative, which means it's gaining, which means it is reduction. All right, so remember, whenever you're working through these questions on the mastery, you need to identify who's oxidized or reduced and put everything that's with an oxidation, that's one half reaction. And of course, everything with reduction is our other half reaction. So here we go. I'm going to scroll this up just a little bit, and let's write our half reactions. Remember, it doesn't matter who you write first. Here we go. Let's go through and balance, right? So it doesn't really matter the order that you balance these in. We'll start with the top one. Remember, we want to balance everyone except for oxygens and hydrogens. I can see that my chromiums are balanced, which is exciting. Now let's balance our iodides. Notice I have 3 on the left. So notice I've got 3 on the left, but only 1 on the right. So notice now that everything except for the oxygens are balanced. Let's figure out our oxygens now. So notice that here we have 4 oxygens, and right there, 3 times 4 is 12. So we have 12 plus 4, which is 16. So we have 16 oxygens, which quite a few, all things considered, but nothing too crazy. We're going to add those over here now to balance that out. So 16 H2O, that'd be liquid phase. To balance hydrogens, we always add H+, and I failed to mention this at the start of this question, but we are balancing this in acidic solution. All right, so notice that we'll need a grand total of 32 H+'s to actually be able to balance this reaction. So now notice that our top reaction seems to be good to go for elements. Now let's balance it for charge. I will let you figure this out, but notice that the total charge on the left is 0. The total charge on the right would be -2 plus 3 times -1, so -2 minus 3, so that's -5. Oh wow, here we go, plus 32. So we've got -5 plus 32. So that's got to be 27. And that'd be plus 27. That's quite a few. So we're going to have to add 27 electrons to that side. Top half reactions now balanced. Let's do our bottom reaction now. So notice that 2 chlorines on the left, 1 chlorine on the right. Balance that away. Now notice we're balanced for elements. We don't have to worry about oxygens or hydrogens in this case, which is great, which now we move on to charge. The sum of the charge on the left is 0. The sum of the charge on the right is -2. So the way that we're going to balance this out is if we add 2 electrons over here. So at this point, we now have our balanced half reactions, which is great. It's now time to recombine these into our final equation. So notice that the one fundamental thing when we go to recombine from our balanced half reactions is we need the electrons to cancel. So I've got, of course, this gargantuan 27 there, but only a 2 there. And we need that least common multiple, right? What number do I multiply them? I'm sorry, the least common multiple. So that'd be 27. So that's going to be 54. So we've got to have 54 electrons to balance this out. So, all right, here we go. So that means then on this top equation, okay, on the top equation, I have to on this top equation, I have to multiply everything here by 2. And on this bottom equation, I have to multiply everything by 27. Okay, and here we go. And so now when we add, everything should work out perfectly. Better write small. Remember, everything on the reactant side gets added together, arrow, everything, summed on the product side. So we have 2 times 16, which is 32 H2Os, plus 2 times 1, which is 2 chromium-3 iodides. We have, all right, so now we're going to move down to our second half reaction to sum all the reactants together when we add the 2. So that'd be 27 times 2, which is 54 electrons, plus 27 Cl2 in the gas. And now we're finally to that arrow. Moving back up to the top equation, again, we're doubling all of those things, so remember that. So that'd be 2 chromates, plus 6 periodates, plus 64 H pluses, plus 54 electrons. And then last but not least, 54. So moving to the bottom of the equation, we still have that 2 chloride ions that we need to write, but that's times 27, so that's 54 chloride ions. Whew, that's a doozy. Okay, so I'm just going to draw a little line here just to kind of split this up in our view. Now what we need to do is go through here and cancel everything that we possibly can. Obviously, that should always happen, so those are gone. So that's about it, really. And so here we go. I know it's long, I know it's tedious, but again, don't stress too much. These are honestly nothing crazy. Once you start learning how to do them, man, they really just come together. Take care.